Hey everybody, thanks for stopping by for another Screwy Tuesday. Got a couple things here to show you in my shop, and then we're going to have a visit with my good friend Carl. So this last weekend, my good friend Flea Market Dave and I went to the past tool show. It was their tool show down in Spreckles, California, which is Salinas, and it was real nice. Got to see a lot of the friends there, and it was really cold. As you can see, it's cold here today. What is it? It's only 55 here in the shop, but it's been cold. Anyway, we had a really good fun day. I didn't buy a whole lot of things, but let me show you what I did get. One of the first items I purchased, this is Starrett's 271s, a set of V-blocks. I don't think the camera's going to show how beautiful they are. I haven't cleaned them. They're case hardened, and matching set of V-blocks with the clamps. I paid $30 for it, and the $30 also include another Starrett tool, which I don't know where I put it. It's a hook rule, 8-inch hook rule. This from Starrett News, about just south of $150. So as soon as I saw the case hardening, there was no way I was going to go back out of my hand, and really happy to purchase that. The other thing was these are Starrett. These aren't Starrett. Somebody made these. They're Starrett design. Got a note here, 54, which are vise hold downs to pinch in the vise. Picked them up. I think you can see they're magnetic, so I think I can use them on the surface grinder also for pinching parts. But they work in a non-curt vise, is where they're really designed to pinch on something you're trying to hold. These were shop built, and I think I paid the guy $10, a friend of mine. Happy to get those. And then I walked over to say hi to a friend, and he was standing at a table, and I looked at the little sign on the table that says free. You know, free. And then I looked at him, and there in his hands are multiple Starrett boxes. Inside my, I didn't look much further than that. I was kind of peeved that I wasn't there before he got there. But what I did pick up was you can see it's an older boring bar holder. It says Long, L-O-N-O on the back. Probably, I don't know if it's made or not, you know, home shop made or whatever, but picked it up. And then the other item I got, and I started cleaning it up. Oh, this is a Ken tool, a axle or hub puller. It's a beast. It's cleaning up really nice. It's really in primo shape. It was sitting there. You can see what it looked like before I started cleaning it. Gonna end up painting it with the hammered silver. Be in the toolbox for the day I need it. Again, I said, as I mentioned, we had a great time at the past tool show. It's Tool Collectors, Northern California. They hold 4 shows a year, and it's $20, I think, to belong to the membership. $25 for the year, and a lot of great guys. This time there was quite a bit of machinist items there. Typically, it's much more wood related, but there was quite a bit of machinist stuff there. So before we go see Carl, as I was over filming with Carl, we had a little discussion about my project here. And you know, it's sometimes you're in the forest and you can't see the trees. So let me rotate the camera here for a second. I'm going to go handheld for you just to talk about this. So, as you know, I haven't proceeded with this since I picked up the Northridge grinder, and I'm playing with that. But as I mentioned, I'm adding these posts so that I can put the tabs on here. The Fireball tool now casts these posts into the design. So my plan was, you know, I'm going to have a post on both sides, and I'm going to have to have a threaded rod to tighten them. And I've been hemming and hawing how I was going to do that. And I actually was fooling around and tried making a smaller rod out of a cap screw to see if I could screw the two together and still use a 1/4-20 as my attachment for the tabs. And so Carl and I were talking about it today, and it's just too funny. I was talking about using a smaller cap screw in here for the attachment so that I could get the 1/4-20 thread in here still. And I think I was almost down to a number 6 to make it work. Even then was not really going to work. And honestly, I can't think of who thought it up. I think at one point I was saying, you know, I don't want to put cut hexes on this and then try to hold it. It'll be in a corner on some of these, and I'll mess up the aluminum since it's all aluminum. And I was talking about, you know, using a cap screw on top and try to tighten it down, and I said I just don't want to cut hexes on it or whatever, everything. And it's somewhere, and I can't remember if Carl thought it up or I thought it up, but it was just so damn simple. All right, guys, I got a lot of technical people out there. What's the simple fix to tighten these two pegs to each other? Of course, I'm going to put a threaded rod in there. Make it a little bit taller, and I got a sacrificial top, and I can put a pipe wrench, channel locks, I can cut flats, whatever I want. Tighten these together, and then of course I'm going to mill them off anyway so they're flush. And it was like, are you kidding me? Just too simple, but sometimes you overthink things and you forget to, the old KISS, keep it simple, stupid. So anyway, got that figured out. That took a lot of pressure off me. That's been something that's been bothering me on how I was going to do that. My good friend Robin Renzetti suggested picking up some Loctite products to also use as an adhesive that would bond it to the base and bond it to the wall. I've got all those products now, and so this should be moving forward. All right, enough of my yakety yak. I appreciate you guys stopping by for a Screwy Tuesday, and we're going to take a shot over to Carl's. It's a follow-up from our previous video, and there'll probably even be another follow-up from him. But hope you enjoy it, and again, always appreciate you guys stopping by. Thank you.
Well, hello there to Chuck's subscribers back in Carl's shop. I've made some progress on the lubrication system for the mid-sized import mills, and I want to show you a little bit about what I've done. Before we get going, I've used these gloves from Memphis Glove for years. They're made out of 100% Kevlar. They have gripper buttons, but the thing I like about them is that the fingertips are cut off, so that I still have the manipulability, the touch, but it keeps the body of my palms warm. So I use these regularly in the shop because I don't heat my shop any higher than 55 degrees. I get a little chilled. I'm kind of a slender build, and there's not a lot of meat between the outside and my bones. Now, one of Chuck's subscribers, I believe goes by the name of Traditional Tools, showed up with a box of milling machine 40 taper tooling, and he says, "Here, I don't have any use for this. See what you can do." Well, this is some really interesting tooling. I've never seen anything like it before. Made by Thurco. I know them as makers of slitting saws. I've got a couple of Thurco saws. So I took a look at these things, and I go, wow. I go, first look at them, and the interesting thing is there's no closing taper. That's through threaded. That's a parallel thread. The collets are parallel. It took me a while to realize what it was, is that you probably can't see this, but these are buttress threads. And this is the first time I believe I've seen a buttress thread on any tooling. And clearly, when the nut gets down here and begins to secure, it closes has a parallel closing action on all of these threads. So let's put it together. Here's the collet. Drops in. Here goes the nut. And by the way, there is a cone. I see now there's a cone down here, but that's not part of the closing. The tool goes in, very nice fit. Here it's still loose, there it's tight. So this is a most interesting tooling set. I didn't use it here for this particular drilling operation because I needed a 1/2-inch collet, and I've only got a 3/8 in this size. But as I said, it's very nice. Here's the bigger one, big monster, and here's a collet for it. And quite interesting, it also includes a reducer from the larger to the smaller size. And then looking in the box, there is yet another reducer from this to a still smaller tool holder. So there are apparently at least 3 basic size tool holders in this system. And again, thanks to Traditional Tools for the additional tooling to fix up this mill. The next thing, you want to...
You can scoot a little closer.
Chuck's going to move a little closer.
There we go.
For work on the mill, I like to do a lot of bolting down, and so I keep what I call bolt boards, and they are just simply a piece of plywood with holes drilled in them. And I can have all of my screws in one place. There's 4 of each size, and this goes from 5/8 to I think 4 inches, something like that. A couple of nuts laying around and some washers. And these go in the bottom drawer of my toolbox. I have in that drawer everything from 1024 to 1/2-13, and it's just a matter of an instant to open the drawer, pull out the bolt board, and bolt something down. So we'll put that away. Here's where I am on the lubrication project. This is a saddle from what I believe to be a Grizzly mid-sized import mill. It's bigger than the tabletop and smaller than the Bridgeport clones. And for my shop, it's just a wonderful size, lightweight, very smooth operating mill. I am currently drilling and tapping a port to supply oil to the gib down here, and then this will get the tap hole will get a pipe plug. The circuit, the oil circuit in here is kind of complicated, and it violates a couple of rules. The main rule is that in general you don't want to have parallel paths. You don't want to enter the oil here and then go this direction and go this direction, because it's possible for one direction to be starved depending on the resistance to fluid flow. It is better to have them fed in series so that the pressure appears along the full length of the path. Unfortunately, I had to deal with what the manufacturer originally did, which was this and these holes that he already put in here. So I violated the rule, and I have here a parallel path. It's going to feed, it feeds in here, down here, and at this point it's going to go down, and then I have a cross hole here that feeds into here. So there's just, I can't, actually this is the end of this particular circuit. If I were to turn it over, you would see where the parallel split occurs. I just simply can't avoid that. The second rule that this violates is that you don't want to have a straight path, because it is possible for the mating surface to wear down into this, and then if that surface goes and leave a high spot on the mating surface, if that bumps into this, then you get a lift on the table. So in general, it is better for the paths to be zigzag, and I'm going to show you that in just a minute. Take this off. Now we're going to take a second and see if we can focus the camera on this work. Can you see that, Chuck?
Yeah, I can see it from here.
Okay. When I started this project, I had no idea how I was going to cut these grooves in the angular surface of the dovetail. The flats were easy. You can do that with a chisel or any other method. I was into the local big box store and got to thinking that, well, okay, how do I look at the Dremel supplies? And I bought a ball burr. Oops, we're getting a better look here at things, yeah. And I laid this out, and it took me maybe 10 or 15 minutes just to grind these in. So you'll see, I'll show you later how these are laid out. But there are cross slots, and then they're angular, so it distributes the oil the full length and across the surface of the dovetail. All right, there's those details. And we're going to show you the next over on the big mill. Okay, I want to show you how the oil paths are machined into the gibs. These are tapered gibs, and so the back side of the gib is sealed against the casting, and oil comes through the port and then is distributed along here. This slot allows for the gib to move up and down with respect to the entrance oil port. And so this is setting up to do that. Then if we turn it over, this is the sliding surface of the gib. As I said, this is a fixed surface. It only moves enough to adjust for the fit. This is the oil porting, and you can see how I have avoided any longitudinal lines by by angling them, and then to provide a cross slot to distribute the oil across the surface. And I just do this kind of rough. I just set this one out, and by eye I did this. I will probably change it. I did this just to show you guys how I do it. An interesting thing, and I don't know that you can see it very well, this gib was not fit. Frankly, I don't think it was fit at all because it only has a few bearing spots like this. This is the table gib. You can see here there's a lot of clearance, and this is where the oil has pooled and oxidized. So I'm going to clean this off, put the gib back in, and I'm going to refit both the back side and the front side. So there's quite a bit more work. I was trying to avoid any scraping or rebuilding on this mill, but I'm going to have to scrape this one in. Okay, we're going to go next to the knee and see how the tubing has progressed on that. Well, I got to confess that this job has taken a lot more time and a lot more money than I ever expected it would. I'm gonna punt on the question of was it worth it or not. You know, we do these projects, and some of it's for fun. A lot of it's for learning experiences, and as you know, that's what Chuck and I are both about. We're out here just figuring out things and having fun. So this mill was equipped with a oil pump and a rudimentary oiling system by the manufacturer. The reason I stopped using it was that the pump, you put oil in the pump and it came right out of the bottom. And I finally took that old pump apart and discovered that it was a manufacturing defect. There was no way it was going to be fixed. So I bought a new one. And I was fortunate it was by the same manufacturer, and I certainly hope that they got that defect fixed. And quite happily, it took the same mounting holes, takes the same space, and so I'm off and running. I have the first layout for the piping, or tubing. Discharge port is coming here to this Bijur distribution block, and out of the block, then I take individual circuits off to the various parts of the mill. These are just temporarily set in. They're cut over length. I'll show you on the other side a little bit more what it'll look like. And so let's go over there right now and take a look at that. Okay. The pump has two discharge ports, one on each side, and so I thought, well, that was a nice way to split the circuitry on this mill. So the one port takes care of the right-hand side of the knee and saddle. The other discharge port takes care of the left-hand side. So here's the cross tubing, and it feeds this distribution block, and it feeds up to these three circuits on the knee. Ordinarily, there would only be one circuit to the knee, but because of the problem that the manufacturer relieved this part of the flat by 2 3/1000ths, that's a low-pressure leak path, and so I split the knee lubrication, the knee to column lubrication up into an upper section, a lower section, and the gib. I just didn't see any other way of easily doing that. Each of these discharge ports, and there's going to be 5 of them, will have a meter unit. These are essential for this type of pump system because it divides the fluid flow from the pump to each of the circuits in the system, depending on the area and length of travel of that particular circuit. That way, if there was not a meter unit, then most of the oil would flow to the lowest resistance, and a high resistance area would not get any delivery at all. So that's the function of this meter unit right here. And here is the nut that connects the tubing. It contains a filter, a meter unit, and I'm not sure how they work, and a check ball. Thank you, Chuck. So that's a complex item, and in general, just I'll mention is that these are considered renewable. They're replaceable. They're not really repairable. So if you have problems with your meter units, throw them away. They're about $15 right now, and it's better to buy them than to try to fix them.
And you were happy with H&W?
Oh, yeah. Yeah, Chuck's reminded me that I bought all these parts from H&W Machine Tool Rebuilding, I believe. I think they're in Ohio. Can't remember for sure. They've provided most excellent service, and I certainly recommend them highly. So there you have, oh, one other thing. I want to tell you guys something you don't do, and that is, oh, and this will also show you how the gib goes in. Can you see this up here, Chuck? We're going to move the camera just a little bit.
Yeah, I think we're good. Yeah.
Here's that distribution slot that I told you about. Here is the inlet port, and so you can see that the oil going into here will go, this hole was drilled at the same time this hole was drilled, so it's going to go through here. Again, allowance for the gib to be moved up and down. There's the distribution line. What I want to tell you is, when you put a knee gib in, don't drop it, particularly on a Bridgeport type mill where the adjustment has a screw with a slot. If this drops too far, it can jam, and knee gibs can be extremely hard to get out, so be very careful. On this particular mill, there's a screw down here, and it is adjusted properly, so I can carefully drop that down, and then its screw goes on the top. So this system with 2 adjusting screws works very nicely, and I like that one. So there's progress. Plenty more to do. I'm going to do one more quick video at about the end, and I want to show you at that time how I've worked out the problems of lubricating the lead screws and see the finish of the project. Thank you very much for your attention. I've had a good time with this, and I enjoy making the videos for you guys.